When thinking about friction, a good place to start is to try to figure out what does friction depend on. If I rub two things together, how do I know how much friction it's going to feel? One thing that immediately comes to mind is how rough the surface is, right? So if I rub two things together that are smooth, it's not going to have much resistance. If I rub sandpaper against something smooth, there is going to be resistance, and a sandpaper against sandpaper is going to be even more resistant. So a value that quantifies the amount of roughness of the two surfaces is called the coefficient of friction. The coefficient of friction, we use the Greek letter mu for, which looks like a combination between an M and a U. It looks kind of like this. So that's mu. The other thing that it's going to depend on is if you rub your hands lightly across the surface, you don't feel much resistance. If you push them hard and rub them against the surface, you feel more resistance. So the other thing that friction depends on is the normal force, which we denote as N. In both cases, if you increase roughness or you increase normal force, you're going to increase friction. So it turns out that the force of friction, generally, is equal to mu times the normal force. We do have to be a little bit more careful, a little bit more specific when talking about this, because there's actually two types of friction. There's static friction, and there's kinetic friction. Now, static friction, I can push against this chair. I'm pushing it very lightly, and it's not moving. I'm pushing it harder now, and it's still not moving. And now I'm pushing it eventually, and it does move. So the fact that I can increase the amount of force that I apply, and some force, friction, is stopping it from moving, means that this friction, static means at rest, it's not moving, right? So static friction is the friction that two objects feel when they're not moving relative to each other. And static friction can have a whole bunch of different values, right? It can have a very small value. If I push lightly, I'm going to have a small amount of friction back. If I push hard, I'll have more static friction back. If I pull really hard, I go into kinetic friction, where kinetic friction is two surfaces that are moving relative to each other. So if I was to graph my force of, force applied versus my force of friction, I'm trying to figure out which axis I want to do this on. This is going to be the force of friction, and this is going to be the force applied. So, as I apply a greater and greater force, my friction force is going to increase. And this is static friction. But then all of a sudden I'm going to switch into kinetic friction, and it's going to start moving. And when it does that, it requires less force to keep it moving than it did to start it moving. So I'm actually going to get a drop, and then a constant. So force of kinetic friction, this is the realm of kinetic friction. And this is the realm of static friction. Static friction can change. So the force of static friction is always less than or equal to the coefficient of static friction times the normal force. The coefficient of static friction is distinct from the coefficient of kinetic friction. And that's because static friction can have a greater maximum value than kinetic friction. Kinetic friction is equal to the coefficient of kinetic friction times the normal force, like that. Those are the two types of friction and how you will write them. A lot of times in problems you'll be asked about the maximum value such that an object doesn't move. The maximum value of mass, the maximum amount of force you can pull without an object moving. In that case you can just set these equal, because the maximum amount is mu s times the normal force, right? It's not anywhere less than that. So, let's look at how you apply this in a problem. It's actually not super hard to do. It essentially is just another force to remember to include. So let's say that you have a box, and it has a mass of m, and let's say it's being pulled to the right with a force of F, and it's being pulled to the left, well, not pulled, but it feels a force to the left as a result of friction, right? So this force to the left is the force of friction, which is equal to mu k, because we're going to say the block's moving, times the normal force. So what's the normal force on this block? Well, it pushes down with the force of mg, and it feels a force up from the ground pushing on it of mg. So our force of friction here is equal to mu k times mg. So now if we want to find the acceleration of the block, we can just add up our forces, and it's going to be F minus mu k mg is equal to ma. In solving for A, we get that A is equal to F minus mu k mg divided by m. So, all you have to remember is, and how do we choose what direction friction goes in? Well, you guys know from experience, if you push something, it resists the direction something's sliding or is kind of rubbing it. So if it's moving this way, it's going to feel a friction force that way, as if it's sliding. So that's how you use friction and apply friction into problems.